Hi everyone, Mr. Chalman here. We're going to be talking about Unit 6, Lesson 10 practice problems. Okay, so these are on page 91 and 92. We're going to be doing problems number 1, 2, 3, 4, and 7. Okay, so let's go ahead and jump in and get started. Okay, so number 1, the quadratic function f is defined by f of x equals the quantity x minus 7 times the quantity x plus 3. That's just how you read these math sentences, right? Okay, without graphing, identify the x-intercepts of the graph of f. Explain how you know. Okay, so if I were to graph this, remember from the lesson that these two numbers are my x-intercepts. Okay, that's where like the parabola intersects the x-axis, right? And the only thing we have to do is switch these signs. So I'll have one over here at plus 7 and one over here at negative 3. So the x-intercepts are these two numbers, but with opposite signs. So the first one is 7 comma 0, because remember that's where it intersects. That's the point on the x-axis that it intersects. And negative 3 comma 0. So these are my two numbers, 3 and 7, and I just switch the signs. And they happen at a height of 0. So that's what this second number is, this y. All right. Expand this expression and use the expanded form to identify the y-intercept of the graph. So the first thing I have to do is expand this, right? And we use the distributive property to do this, but I like to call this the rainbow method, right? Just like my pencil. It's a happy birthday rainbow colored pencil. All right. So I'm going to take this first one and I'm going to draw a rainbow arc to the first term over here and to the second term in parentheses over here. So x times x is x squared. X times 3 is 3x. And I'm going to do the same thing with this term, negative 7x. So now I'm going to do it like underneath, like an upside down rainbow. Okay, so negative 7 times x is negative 7x. And negative 7 times 3 is negative 21. Okay, all I have to do now to simplify this is combine my like terms, which are these two right here, and I get x squared minus 4x minus 21. Okay, so if I distribute these two numbers, this is what it transforms into. This is the standard form of a quadratic equation. Okay, now in order to find the y-intercept of the graph, right, all I have to do is make these x's zeros. So 0 to the second power is 0. Negative 4 times 0 is 0. And that leaves me with negative 21. So if I put this at 0, and this is 0, I get 0 squared minus 4 times 0 minus 21, right? So this is when y equals 0. No, not y. When x equals 0. So if I move back and forth, 0 is where the y-axis is, right? So in this case, this is just 0 minus 0, which is 0, and it leaves me with negative 21. So this number right here is my y-intercept. And you can see it's the same right here. It's the number without a variable on it. If there's only one, then you're all set. If there's more than one variable, or if there's more than one term without a variable on it, you have to combine those two to figure out what it is. Okay, so my y-intercept in this case is 21. We'll go 0, comma 21. Because we set these x's equal to 0 to figure out that it was, negative 21. Sorry. Okay, that's the end of the first one. Let's move on to problem number 2. What are the x-intercepts of the graph of the function defined by x minus 2 times the quantity x plus, or 2x plus 1? Now this one's a little different because I've got a 2 right here. Okay, so I can already tell this is one of my intercepts. So one of them is 2 comma 0. And the other one, now, if I said it was just 1, you know, why is there 2? What does that 2 do here? Well, if I graph this, you can see from the graph that I have one intercept right here at 2 And if this is 1, then the other one is right here at about 1/2. Okay, so this one looks like this. That's what that looks like. Oh, you guys can't see it. Sorry. My bad. Okay, so here's the first 0. If I graph it, the parabola looks like this. If I put this whole thing into Desmos, the graph turns out like this. Okay, and I can see that the other one is 1/2. Well, how do these numbers compare? Well, all I did was I took this number and I put this number underneath it. And I get 1/2. And remember, you have to change the sign. Oh, it wouldn't be right there. It'd be negative 1/2, wouldn't it? I like it when I make mistakes. Is that weird? Right here. Negative 1/2 is right there. Okay, so my second 0 would be negative 1/2, 0. And if you look down here, here it is, right here. B. Why don't I do this? Okay, so my suggestion to you is if you have something that you're not sure of, like this 2 in front of the x, graph it and then see what happens. Okay, all right, next. Number 3. Here's a graph that represents a quadratic function. Okay, so that's what this red thing is. Which expression could define this function? Now, if you look at these, right, these are in factored form, which means they tell me where the zeros are. Here are the zeros. Here are the x-intercepts. All right, so where does this sucker intercept the x-axis? This is the x-axis. Well, it intercepts it right here at 3, 0, and it intercepts it right here at negative 1, 0. Okay, so those are my 2 x-intercepts. And these are my 2 numbers, 3 and 1. And remember, we have to switch the sign to put it over here. So instead of a negative 1, this should be positive. Instead of a positive 3, this should be negative. So if I look over here, positive 3s are up here, negatives are down here. So it's one of these 2 down here. And all I have to do is look at this and say switch that sign. So it's not this one, it must be C. Woohoo! All right. So all I'm doing is switching the signs on these x coordinates when I put them in here. Right? Next page. Okay, number 4. What is the y-intercept of the graph of the equation y equals x squared minus 5x plus 4? Now remember, all I have to do is just plug in zeros for these x's, and whatever's left over will be my y-intercept, right? Because as I move left and right on my y or on my x-axis, as soon as I get to the y-axis, that's where x equals 0, right? So if I drew a graph like this, well, here's my y-axis, this one that goes up and down, and here's my x-axis. And as I move along this way, the y-axis is located at x equals 0. Right? So this is 1, this is 2, this is 3, this is negative 1, negative 2, negative 3. So right here is a 0. So if I just plug a 0 in where these x's are, that should tell me where on my function my parabola crosses the y-axis. So 0 squared minus 5 times 0 plus 4. Well, this just becomes 0 minus 0 plus 4. Okay, so these cross out and I get y equals plus 4. So my y-intercept is at 0, 4. So in other words, it's up here at 4. Okay. An equivalent way to write this equation is y equals x minus 4 times x minus 1. What are the x-intercepts of this equation's graph? Now the x-intercepts are where my parabola crosses the x-axis, right? And so that's these 2 numbers. and I just have to flip the signs. Right? So that's it. Positive 4 comma 0 and positive 1 comma 0. So I just took these two numbers and I changed the signs. That's all I did. Okay. Let's go all the way down to number 7 and we'll wrap it up. I love this. Write each quadratic expression in standard form. Draw a diagram if needed. Now, standard form, that's that ax squared plus bx plus c. Okay, that's what this is. All right, so all we have to do is use the distributive property or the rainbow method. I like the quotation marks. The rainbow method, right? So just take this number and multiply it by each one of these things. So x times x, that's x squared. X times negative 6, that's negative 6x. And negative 3 times x, that's negative 3x. And negative 3 times negative 6, well, negative times a negative, that's positive. So it'll be positive 18. Now we're not done because we have to combine like terms. Right? So let's put these two things together. So this should equal x squared minus 9x plus 18. Okay, so that's your final answer for that first one. Okay, let's do the same thing here. Ooh, this one's tricky, right? Because I can't like distribute these things to this. But what this means, it's the same thing as saying taking everything in this parentheses and multiplying it by itself. So I can rewrite this as x minus 4 times x minus 4. Okay, now I can do my distributive property or rainbow method to figure this out. Okay, so x times x equals x squared. X times negative 4 is negative 4x. And negative 4 times x, whoops, is negative 4x. And negative 4 times negative 4, oh, negative times a negative, that's a positive. Positive 16. Okay, almost done. We have to put these two together though. So this becomes x squared minus 8x plus 18. Notice I just took these two and put them together. And that's my final answer right there. Okay, let's do it again. Down here, oh, this one's easier than this one because I didn't have to rewrite it to start. Only difference is now there's a number in front of this x, which is fine. Don't let that bother you, right? We're doing the same thing. We're taking this entire 2x and we're multiplying it by x. So this becomes 2x squared. And now 2x times negative 4. So we just go 2 times negative 4 is negative 8. And don't forget your x. That buddy comes with him. And then we do this one. 3 times x is 3x. Positive. That's why there's a plus there. And positive 3 times negative 4 is negative 12. All right. Combine your like terms. And that equals 2x squared minus 5x minus 12. And the very last one, ooh, these ones have numbers tied to both these x's. This will be fun. Just what you wanted, right? Okay, 4x times 3x, that's 12x squared. Don't forget the squared, right? Because we're multiplying these x's together too. All right, and then 4x times negative 7, that's negative 28x. And then negative 1 times 3x, negative 3x. Negative 1 times negative 7 is positive 7. Okay, combine like terms. This puts me at 12x squared. Don't forget that beginning. Negative 28x minus 3x, that's negative 31x plus 7. Woohoo! A lot of work, right? But we're exercising, right? We're exercising our math and algebra muscles with this one. So, if you guys have any questions with any of this, please write me an email for your math teacher and we'll get you straightened out. I hope that helped. I'll see you next time. Mr. Chalman, logging off.